Hello and welcome to this ActionHeat webinar on demonstration of Citiwatts Toolbox. My name is Mostafa Falanejad and I am a senior researcher at eThink Energy Research. So what is the Citiwatts and what is Citiwatts Toolbox? Basically, Citiwatts is originating from RUNET research project, which is called OpenGIS for Energy Transition. The project started in 2022 and will end in 2025. The main idea of the project is to bring the hot maps platform to a higher technology readiness level. Basically, hot maps was developed for technology readiness level 7, and here the aim is to bring it to the technology readiness level 8. On the right-hand side, you see the list of partners who are involved in OpenGIS for Energy Transition project. Some of the partners are partners who were involved in the Hot Maps project as well, and some of them are new partners in the consortium. The Hot Maps platform is accessible through hotmaps.eu, and the Citiwatts platform is accessible through citywatts.eu. But what are these improvements that are expected to be seen in the Citiwatts platform? Basically, there are like different aspects that are going to be improved. The first aspect is adjustment in core calculation modules for heating. So the Hot Maps Toolbox not only were for showing visualization of the datasets, but also for manipulating and doing some calculation on those datasets and coming up with new indicators and better understanding of the heating system. Here in the Citiwatts platform, those calculation modules have been improved and new features and functionalities have been added to them. Additionally, there is a new calculation module which is for district cooling. So more attention have been paid to the district cooling as well. Furthermore, the basic mobility tool have been replaced with a more sophisticated e-mobility tool, which adds some additional indicators to this calculation module. And finally, there is another calculation module which aims to integrate analyzing the flexibility and other energy system aspect to the Citiwatts platform. On top of what you can see here, and it's directly seen by the user, there are like improvements on the platform side, like improving the usabilities, user experience, and also technical improvements, so that it's also um, leads to a more stable platform compared to the hot maps. Generally, in this webinar, I'm going to introduce you the Citiwatts Toolbox, different functionalities of it and menus. And on top, I will show you the user account, how to use it, since it's important for certain workflows. And later on, then I will show you calculation of future heat demand, which will be used for identification of potential district heating areas in a city. Now let's have a look at the Citiwatts platform. Once you open the Citiwatts platform, you see the project information page. You need to navigate down and press the Go to App button in order to open up the application. On the top, you see the menu to the menu of the platform where you can click on project information again, or you can use go to place to navigate to a certain city or place. You can use the wiki button to open up the wiki platform of the Citiwatts. You can press feedback button to give information or feedback to certain functionalities or your wishes here, or report a bug. You can also open up a user account. I will come back to this one later. On the right hand side, you also see different boundaries, administrative boundaries, as well as hectares, which are used for different selections. So if you're on a nuts to level, you can select different nuts to levels. As soon as you start selecting, you will see the tools window will open here, and you see the number of elements that have been selected here with the bounding box in the area of it. Then you have the option to zoom in or zoom out, or choose between road display or satellite display. Once you are on hectare level, you have the option to make also different selections, like a free selection or circular selection. You can also clear the selected zones by pressing on Clear Zones. On the Layer tab, you will see a list of layers which are very similar to the ones in the hot maps, with small modifications and new datasets added to the platform. On top, you have the option to directly select the layer. For example, if I'm interested into the ActionHeat site, then I can just press in that one and then select this layer. And if I have multiple selection of the layers and I am planning to disable them, I have the option to press on the unselect all to remove all the selected layers in the map. Again, similar to Hotmaps platform, you have calculation module tab, which you can open, but the calculation modules are inactive since there is no selection on the map. So in order to activate them, you need to first be on a certain administrative level. You need to select a region, and once you select, depending on your selection and the region, some of the calculation modules will be activated or not. So let's have a look into the user account, which will be used also in our um, upcoming calculation for this webinar. The first step to use the user account is that you need to open up an account, and for that you need an email address and a password. If you have not registered, you need first to register. You provide your information and press on register. You get an email, and once you receive the email, you need to activate your account in order to use it. In my case, however, I have already a user account, so I'm just using my credentials to log into my user account. As you can see, when I press on my um, account, I see the information related to my user account. As soon as you are logged into your account, one new button will be added here in the top menu, files, where you can upload different layers and see them here. You have certain amount of disk space, and you can upload different datasets to your account. In order to upload a layer to your account, you need first to select the type of layer you want to upload, and then you need to select it from the disk. And once you select it from the disk, then you need to press upload layer. Now let's navigate to a small city and do our exercise today. I navigate to the city of St. Pölten in Austria. And let's say that I'm going to to calculate future heat demand densities. The first step is that to see what is the situation currently, I can just do it by selecting the layer heat density total and then load the results. And I can see that how much heat demand is available in this selected area. Then when I go back to the calculation modules, let's say that my estimation is that in the year 2050, I will have 10% heat demand reduction in this area. And this, in order to generate this 10% heat demand reduction uniformly in all uh, areas of this selected area, I just need to come to the calculation module and select a scale heat and cool density map. Then I need a multiplication factor and I give 0.9 for 10% decrease and I run the calculation module. What I get at the end is basically a heat demand density layer for the selected region, which has 90% of the original heat demand density. So it would be roughly 1.3 terawatt hour. So you can see also the indicators for the calculation module in the indicator tab. But another output of the calculation module is already in the calculation module layers. So this has been calculated right now and I can download this layer. So what I do is just to download it and wait until the download is completed. And since I want to use this layer for my calculation, for my later calculation, I need to upload it again to the user account. So I come back to the files and here I use heat density total future since it's going to be used for my future application. Then I select from the downloads, like first let's rename it. Think Bolton 2050 with 90%. Now that I have selected my layer, I just upload it to my user account. I need to refresh a few times until it's completely uploaded to the platform. So if I now navigate up, I can see that under the personal layer, which will appear once I am logged into to my account, I can see this layer appeared. So if I disable the default layer and activate the new layer, I can see it here also demonstrated. All right. Now let's go to the calculation module tab again and see how we can calculate the potential district heating areas for this city or selected region. There are two options to estimate the district heating potentials on the platform. One option is calculation module district heating potential areas, user-defined thresholds. This is basically a simple approach to identify the potential district heating areas by setting two threshold values. One is like the minimum heat demand in each hectare cell of the map, and also the minimum heat demand within the coherent areas. And then the calculation module calculates the district heating areas for you. This threshold-based approach is very simple and the results are being shown on the result window as well as in form of charts depending on the number of district heating areas that you have, and you can also press on the selected area or demonstrated area. But there is a more sophisticated approach which I'm going to present now for identifying the district heating potentials. And for this one, I need to come to the calculation module, district heating potential economic assessment. Here, there are a bunch of input parameters that you need to set properly. The first one is the country you are in and also the um, construction cost related coefficients for district heating. Since this is corresponding to Austria, then I do not change. Otherwise, you have the option to change different countries. You still have the option to provide your own values if you think these values are not accurate enough or are not representative for your selected area. You have the option to provide them manually later on. I will come to that point later. You need then to provide the first year of the investment. So in my case would be 2025 and the last year of the investment, which in my case would be 2050. You can provide the current district heating market share within the identified district heating areas, and also you can say what is your expectation of future connection rates within district heating areas. So the first value corresponds to 2025 and the second value corresponds to 2050, so my target year. Additionally, I can say that I am interested in areas that have at least 2 gigawatt hour of heat demands. So any coherent area which does not have such annual demand will not be included in my final result. Additionally, you have the option to increase the threshold for the hectare cells in order to limit your obtained district heating areas. The higher this value, the smaller the region that you get. So if you are planning to see the maximum potential, then it's better not to change this value. But if you are planning to reduce and cherry pick only the areas with very high heat demand, maybe you need to adapt this value as well. Another parameter that you need to provide is the district heating grid cost ceiling. And this value shows that the average network cost within every single district heating areas may not exceed this value. So in my case, I am going to provide 45 euros per megawatt hour to see if I get any reasonable area for my district heating or not. You need to provide depreciation time of your investment and also a discount rate, which could be something 2 to 5, 6% depending on type of the analysis that you have. There are two additional parameters, let's say optional parameters that you can provide. So basically you can say that currently you you are able to expand your district heating network every year to certain kilometer. And for if you provide this and you need to limit your expansion, your annual expansion of district heating networks, then you need to provide also the existing grids, the length of the existing grids, so that the tool is capable of calculating those aspects as well. For this analysis, I do not provide any number, so I stick to default numbers and continue with the next input parameters. As I previously mentioned, you have the option to provide your own cost coefficients. And if you want to do so, you need here to press no, and then add your desired values here. Here I'm going to use the default values and I do not change these default values. So I stick to them and then I continue with the next input layers. So for the base here, I'm going to use the default layer from the Citiwatts platform. And for the future, I'm going to use the one that we calculated together. So the 90% case for the year 2050. And then I run the calculation module and wait until the calculation is finished. It may take a few seconds or minutes maximum until you get the results. And here you see a list of indicators from like total heat demand in selected region or in the district heating areas for the base year and also target year. You also get indicators on the grid cost in absolute term or in specific term, so euro per megawatt hour. And there are there's a distinguish between distribution pipe and service pipes. So service pipes are those pipes which connect the distribution pipe to the buildings. And you can see that in this case, for example, service pipes are cheaper and in total it will cost 44 euro per megawatt hour to connect all identified regions with the given conditions. On top, you get indicators on euro per meter of the pipe for distribution pipe and also service pipes. And also you get the length of the total network uh, for the identified district heating areas, as well as the number of coherent areas. You can also click on different areas, identified areas to get the indicators, but a better approach would be to going back to the layers menu and just navigate to the bottom of the layer, and there you can see the potential district heating areas shapefile, and you can download this layer. So as you can see, for the calculation modules, currently we have multiple layers as we did like multiple calculations. So what I'm going to do now is to remove the ones which are not relevant for us. And you can distinguish between the calculations by the timestamp as well. As you can see, the first calculation we did for calculating the future heat demand density was at as at 126, then 129. The last calculation was 135. So this is the relevant one, and I'm going to download this layer. And once the download is finished, then I can extract the downloaded files. So try to extract them here. What you get here is the shapefile and also a GeoPackage file for the coherent areas that were shown on the map. On top, you get CSV files with the list of coherent areas and corresponding indicators for each of those coherent areas. So you have the option to look at every single coherent area separately, and this is already a good start for your district heating planning. With this, I am going to finish this webinar and hope that this webinar can help you in working with Citiwatts platform. And if you have questions, do not hesitate to contact us. Thank you very much.